Hi, everybody. Now I will talk as a Chief Technology Officer of OpenRules. And OpenRules is one of popular decision intelligence frameworks. We are in business for 22 years. And OpenRules has a business rules engine, optimization engine, machine learning tools incorporated in our platform. And we have plenty of customers worldwide from very large insurance and financial institutions, healthcare, telecommunication customers. And of course, like everybody else, we looking closely at advances in generative AI and looking how to incorporate it in our product. But because it dominates, as I expected, DecisionCAMP, this topic, I will try to stay away from generative AI in my presentation, and I want to see what we can do, how we can improve quality of our platforms without generative AI. So that's why my presentation will concentrate on still on the same objective, how we can help our customers to build their decision models, but in a more simple way. Here is a motivation. When our customer starts a decisioning project, what they usually give at the beginning, what information they're ready to provide? A detailed description of the business logic? Not always, so we hardly can get it. Have an overview of outdated implementations they developed before. Sometimes we receive it, but it's not usually very useful. How about samples of their input data and expected output? They almost always ready. And the customers likely to give you these examples. And can we ask them to give us more examples? Yes, in many cases. So it's our question quite natural. Can we automatically build a simplified but working decision model only from problem samples? And can we do it without LLM? And answer what I will give you today is yes. Because I'm going to present for the first time our advanced rule learner that we made publicly available a few days ago, and we tried to do it exactly to the start of DecisionCAMP. So this advanced rule learner can build working decision model based only on problem samples, and it will let subject matter experts, not necessarily programmers, to test and enhance these initial decision models based on their real understanding of the problem. And I will talk about rule learner. And rule learner is OpenRules component based on machine learning algorithms, but decision intelligence vendors, majority of them, deal with the problem learning business rules from historical data for many, many years. And the OpenRules in particular introduced rule learner in 2007. It's almost 18 years ago, and it was this product was incorporated that time in our business rules management systems and was very successfully used in real world projects from big companies, not even companies, government agencies as IRS, and I will talk about this separately, or several major commercial institutions. And basically what the rule learner did, it could generate rules, business rules, can discover rules in historical data, but as an input, it took different training instances. They include some combination of input variables and expected output, but also it required a user to provide a glossary. And let me show you how it works directly from cloud. By the way, I will try to use not many slides, but use a real presentation presentation. So let me skip to real presentation. And if I go to website, and if you look on SaaS rule owner, you can get the same thing as I speak. You don't need any installation. This is SaaS-based rule owner version. And you can see on the left here, you can have different examples. And let's select a very, very simple one, lenses. This is example when we want to discover what kind of lenses to recommend a patient based on different characteristics of these patients. Maybe it's hard, maybe soft lenses, or maybe no lenses at all. And we can look on this input data. If you click here, it will download this data, and we can just open this data. It's a simple Excel file. This file has different training instances. In this case, it's quite simple table. And this table has, for each customer, it has about 30 different training instances or samples. They describe different age, spectacle prescription, astigmatism, yes, no, tear production rate, and based on these characteristics, it tells you for this particular customer, there were no contact lenses or soft lenses or hard lenses, etc. But to make it useful for machine learning algorithm, we also added a glossary. And glossary is a typical construct for many vendors, but OpenRules presents glossary as a table. In the left corner, we have name of this type of table, glossary, and it has decision variables, the same what we used in examples, and it has their technical names, types, and this is important, possible values or domain of these variables. For example, our contact lenses could be only soft, hard, or none. And the last one is a target, and this target, what kind of contact lenses we would recommend. And if I close this, now I can, so I will take this as my input, and now I can select different algorithms. We actually analyzed 21 algorithms, and most of them were provided by open source, very popular package Weka. And two of them, Reaper and C4.5, generate the best results. And when I say the best, it's usually results that could be understood by humans, interpreted by humans, but also they relatively small, so we can maintain and understand them. So I will select algorithm Reaper, and when I click generate, now it analyzes this input data remotely on cloud, and it will generate results. Let's see, yes, results done, and you can see it immediately tells us this is results, and it tells that generated classification rules have average accuracy 79%. That's important that we immediately tell customer, all machine learning algorithms immediately usually report what kind of accuracy or inaccuracy is there. And you can see some protocol with different metrics, but if you click here on download generated rules, you can see what kind of rules were generated. I click, open, it's again generated in Excel format. And you can see what is inside. It generated these rules, and this is a simple decision table. And this decision table, I will make it larger for you. You can see it actually generated two rules, different combinations of these attributes, and if in all other cases it will produce none. So this is quite simple rules, but we also can know that these metrics, different characteristic and confusion metrics and all other statistical results produced by machine algorithm. But for us, what's the most interesting for subject matter experts who is not expert in statistics, immediately see average accuracy 79%. So this is relatively good, but only 22 out of 24 training instances has been correctly classified. So if we run these rules, they will produce errors. And similarly, I can click select another algorithm, click, and it will generate immediately different rules. They have a little bit better accuracy, 83.5%. And if we download these rules, we will see that they slightly different. Yes, they just have, you can see 4 rules, and according to expected results, accuracy a little bit better than previous one. It doesn't mean that it's always effective, it depends on data, but this is simple approach allowed that our customers easily create input variable. You can actually create your, this is a lot of examples, much more complex examples here, or you can create your own and generate rules, download, and use them inside your model the way you wish. This was a simple approach, but this simple approach helped us a lot, not only to win big projects, but to apply them to real-world applications that you can follow this link and you can read more about this real-world use of our rule owner. So rule owner, we use this, we did not concentrate much on improvements, but when this is what it did, this slide shows, but when generative AI brought so much attention and actually real hype to automatic generation of decision models and business logic, we just saw what we can do without generative AI. Can we improve our rule owner? And we started to think that maybe we should go from rule owner to decision model owner. And on the very, our objective is to build such decision owner models that can take different knowledge sources, including samples, but maybe also description of the problem in natural language, or everything what just was discussed by for example, Gregor or Pierre before. This could be very important knowledge sources, and the objective is that can we generate working decision model. And I want to stress the word working because it's interesting to give user immediately something that works. User can learn from here and can enhance this model. Very important that all this generated business logic would be executable, deployable, etc. So this is our objective, and our advanced rule learner that we just made public is only a step in this direction. And so what we did here, we started with minimal input. And when I say minimal input, it means let's consider only samples with known input and output, exactly as you've seen in this example with credits. And so what we actually rule owner generates. In reality, I will show you this, what it generates, and we'll do real demo. It generates glossary with all decisions, variables, with their types, it automatically recognizes, and also important things, it produces all possible value. They extracted from these examples. And it also generates not one set of rules, but different versions of rules applying different machine learning algorithms, or even without machine learning, it also can take advantages that we already have examples of rules. Maybe we can convert them to almost trivial business rules, but user can improve them as they wish. We also can generate all test cases in JSON format, in Excel format, and etc. We automatically can generate decision diagrams because if rules defined here, so we can give this user diagrams, but we also generate all necessary configuration files, like if it's Java, we use Maven, POM files, and we also can deploy all can generate all facility for different deployment type of this model. So we actually want to have end-to-end decision model and let user to try it and then to enhance this using traditional friendly graphical interface. And I will demonstrate this, how this works to compare with old engine. So I will go to real picture and then I will summarize. So I would go to real demo, and let's say we install this advanced rule loaner. It's very, very simple installation, and you just with one click you download URL and you will have locally something like this, and you will have one batch file, create model. When I click create model, and I want to create right now these credit models, and my input inside is already here. So I would, let's say I will do the same. I want to create a model called lenses. And where should I put this model? Let me choose where I want to locate this. Probably I will go to the folder, this loaner. And in this loaner, I want to put in folder loaner, let's call this lenses. You can choose any name, and all decision model would be generated inside this folder. And I can use different deployment types here. You can just use default regular Java API, or let's select people like AWS Lambda or Microsoft Azure or Spring Boot and secure, not secure. We have all these possible deployment options, but let's select AWS Lambda. And now I need to enter my problem examples. Problem examples, let's see where they are. I do have inside loaner, we have folder learning sources. And in learning sources, we have a lot of different examples. And my examples for lenses, we will try some of them later, but let's continue with these lenses. And when I select lenses, there's the same examples what you've seen. Actually, let me show you this example so I would not hide anything. When I click on these lenses, this is just a regular CSV file. You can see it lists CSV file, comma-separated values. First row gives names of these attributes, and then different value. Very, very simple representation of this data. And now, without, when I have this in place, what should I do? I don't deal with filtering right now. I just tell, okay, create for me decision model. And this create is running right now in real-time generator. So you will see how it generates. So it goes through all, analyzes all this CSV file only. There are no large language models. It just from this very simple information, we're trying to extract as much information as possible. It generates all necessary configurations, and it's ready to, will be ready to go in a second. Yeah, let's wait a little bit. So now it's running tests. Yes. Okay, so we received here, this was a working protocol, but we can look on the results right here inside loaner. It's generated, like I mentioned, these folder lenses, and that's what it generated. I specifically want to open you everything, what this generated structure, so nothing hidden here. For example, you can see different facilities for deployment, for analyzing, but if I click on the rules, you will see different generated rules. For example, the same rules what you saw when we downloaded them, it was Reaper rules, so they were placed in this folder with this accuracy and the other metrics. And you can see C4.5 and all other things. You even can see interesting trivial rules. They just converted our basic examples to decision table, executable decision table. And the only thing what it added, all this, this is single hit decision table. So if nothing, if our new combination does not follow this, and certainly there are a lot of other combinations, could be we will just tell that this decision table does not support this combination of attributes. And user can look at this and use this as a prototype because everything ready for for enhancements of these rules. So, but this is very also simple situation. And now I can run these rules. Oh, there is one more interesting table, how to select generated rules. If I have many of them, I will go to decision table, and here I have include, and it includes its Reaper. If I change this to C4.5, for example, it will execute and save it. It will, our model can select this. Of course, you can do it also on graphical interface. And let's, I will close this. And now I can do several things. First of all, I can test it in batch mode without graphical interface. So I run test. It executes all previous examples against these rules. There should be some errors, right? And if there are some errors, yes, it produced two errors. It tells that there are two failures here out of 24 examples. Two examples failed. So if you look on this example 8 and example 18, they failed. You can see actually the reason, what was expected, but what was actually produced, and all these nice things here. But the only thing what I want to show you is now how it looks in graphical interface, how business user can maintain and enhance this model, how can it be deployed. But at least to be deployed, we should not have errors. Our deployment mechanism tells it always before deploying running tests. So I will go and look on these tests, and let me look on test 8 and 18 was wrong, right? So I will just put here no expectation in rule 8, so it would be, so it would not test, and 18 also no expectation. I will remove it. So nothing here. So now our test, save it, and if I run test again, at least it should not produce any error, so we will be ready for deployment. Okay, let's check that I'm right. Okay, it's running, it's rebuilding because we made changes. Okay, so now this is successful, and now I can go to our already built table, and I can do it more in graphical way. So if I go to OpenRules Explorer, so now I'm opening OpenRules graphical interface, and in this graphical interface, first we will see model. Even a graphical diagram already built, but by default it shows only final goal, contact lenses. Let me show this generated rules. So, and also I can show what was the business concepts were here. So if this was lenses, this was business concept, and I can show me also all my input variables. Okay, so this will all used input variables. So this is my traditional decision diagrams, very, very simple in this case, but at least we can see on this diagram all relationships, and now I can execute these rules. I can execute them, all test cases automatically displayed here, but let's execute them in our debugger. So if I click debug, so now it creates a debug session, and it shows you rules, and these rules, I'm executing the first test. It shows me, I can see a diagram, and for example, test production rule, I can just click here. Oh, it's reduced, and here it's normal. Or it's much better to see in tabular format. You can see that the first rule would not be executed. Our debugger stopped before executing any rules because test production rate is not normal. Here it is reduced. So when I click next rule, it goes to second rule, and second rule is also would not be executed. Then it will go to third rule, and this is default rule will make our contact lenses none. So we can click and we got final results. So this is a very, very simple and quick overview. But now I want to show you from here, business user who created this model, and we selected deployment type Lambda. So here you can see Lambda, and by default we have here East. You can change this to West or to Asia, different regions. But now if I click deploy, we will do real-time deployment to AWS Lambda using this OpenRules bucket. And so it's generating our decision service, or you can call this agent, and now it should produce for us URL, endpoint URL that we can use to call from anywhere. So this is in few minutes we can quickly develop a working decision model. Let's see how when it's done. It actually writes to Amazon network, and this is our invocation URL. I will copy this URL copy, or we can use Lambda ARN, but this is already details. We copy this, and now we can run already, not in batch mode, we can run from different test facility. For example, let's say I will start Postman. Many people use Postman, right? So if I start Postman, I can put here in Postman, this is generated model, and my input, so I will put here this URL, and my input, I can take it from generated JSON files, and you can see rule owner automatically generated for lenses a lot of JSON tests. For example, if I go to this test, if I select this test, copy, I can close this, and I go to my Postman, and I will tell body, and if I select here and make Control V, I got my test in JSON format here. So when I click send, it will run already deployed Lambda. It takes a little bit time initially because Lambda is always sleeping. And now if I run second time, it would be much faster. So it took only 0.3 milliseconds to run this simple decision model. And this is real. I can do testing from here. For example, if I change astigmatism to no, so, and click again, so it immediately created contact soft. If I made it not normal but required, send. No, it's no contact lenses required for this person, etc. As simple as that. By the way, you can interrupt me anytime. If I do this too fast, I can show you more, but I don't want to hide anything. This is straightforward, but what we actually got now. We received, if we go back to presentation, so what we did, our subject matter experts gave us a CSV file. And this CSV file, or it also could be Excel file, JSON file, but we saw CSV file. And from this CSV file, we ran rule owner. Rule owner generated our initial prototype, we call this, of working decision model. It can have a glossary, it can have multiple business rules, test cases, decision diagrams, and it can deploy and execute this model, and the user can continue in this loop, enhance this model. So this is I don't know, somebody will find this impressive, somebody just kind of straightforward approach, but this is very, very practical because even during demos for our customers, when we show this and the person after giving us 5, 6 samples, we convert them automatically to 200 samples. It's quite impressive to have something working already in their hands. Okay, and so let's continue using this, and I can skip this. So based on the previous version, we don't require anymore this glossary because we generate it automatically, and we provide different algorithms, and you can see you already seen these results. So now I want to show you a little bit more, and this is I want to talk about filtering. The problem is that in real world, when people, when your customer gives you input data, not all problem samples represent the output expected goal adequately. So you need to do some filtering of these samples, and usually this filtering done in database with SQL queries, or it's one of the most important tools for creating practical decision models. And what we did, we provided special filtering rules, and I want to show you using another example, decision models that actually, based on different characteristic of person, can define that this person has a good status, credit status or bad credit status. So let's look on this example, and I will use this example. This example has 1,000 problem instances, and you can see it has quite a lot of characteristics, but we will use them to generate right status. Is it a bad status, or this is a good status? And I will go directly to graphical interface. And so I will go to my loaner, and I want to create another decision model. Let me close the previous one. And I will create new decision model. This, I don't need this anymore. Create decision model, but this time I want to filter them. So if I go to this model, I will call it credits, and I will select this where I want to put this model. I want to put this model in folder loaner, and I will call this credits. And now I can use Lambda, I can use Spring Boot, let's say Lambda again, and here I would select my CSV file with this data is from learning source, credits, they here, no, not this one. And now I also can select filtering rules. And before I select them, I want to show you these filtering rules. For credits, we have interesting here credit filter. And this, I will make it bigger. It's a simple table. What we want to do, instead of using all instances, we want to select only instances for people who are foreign workers and who are these foreign workers who are older than 30 years old. You can use any attributes here, but what is important, this is our selection criteria for filtering, and then we can just add this filter, this training instance filter. This is name of this filter, and it will add to filter instances, and our rule owner will use already filtered instances, only instances that satisfy this criteria. Very simple for business people to do it. You don't need complex SQL queries, and you can use here any combinations and not one rules, multiple rules with all exceptions, and it could be quite serious things. It depends on what your classification parameters and a lot of other attributes could be added in these rules. So when I go now to back to my selection, I will try to select these rules. I go here, select these rules, the filtering rules located in my learning in this credit filter file, what you saw. I click open. So now I got filtering rules also. And when I say create, it should generate for me the proper model. So it generates a model. Now it's this model only for this foreign worker 30 years or older, and it's done. And I can, I don't need this anymore. I can close this, and now I can test and deploy this model. And if I go here to learner, and now I got credits, new model, and I can do the same what you've seen with other models. Run them, and I can execute, and it certainly should produce some errors because it's probably not, yeah. And it's, you can see, it's actually ran this Reaper rules, and if it's 39 out of 100 instances failed for these rules, and these rules were here. Let's look on these generated rules, and Reaper rules produced, these rules were produced. And if I look on maybe on what was the average accuracy was 72, almost 73% accuracy for these rules, and there are 5 rules here, right? And if I look on my C4.5 rules, Okay, that's much more complex rules and more difficult to understand. And usually business people can look on them and try to interpret them and see what is there. And you will be surprised how in real life business people like tables like this because they can find some interesting relationship what never was discovered before, because it's basically a machine learning, it's a pattern recognition rules, and they discover interesting dependencies. Okay, if you don't have questions, I would not bother anymore with these demos, so I can do more, but let's go back to my presentation, and you already got the main point. So if I you've seen this. It generated rules with different machine learning algorithms with different level of accuracy, and we can have much more complex rules, but probably what happened before making this public, we applied advanced rule learner for very large insurance financial institution, and this financial institution, they have a lot of business units, and this performance of these units was concerned for some department that looks for the entire company, and they wanted to see how different factors impact performance of these units and how to do some restructuring. And of course, we replaced all names here, but it was about 400 plus combinations of different factors, and they wanted to calculate the results, and it was quite interesting. We got initially results with 68% of accuracy, then we applied C4.5, in this case was essentially much better, and they found that these rules and some factors what they never considered were very, very important for them. So this was kind of success story for us. And now just how I'm doing on time. Okay, I'm still have time. I want to share with you one of the most successful story what we have a while ago when we won several contracts with Internal Revenue Service, IRS, and when we applied, it was not advanced, it was initial rule owner, but what was the problem? That was extremely interesting. So we won contract with IRS when IRS gave us a large volume of historical data comprised of a little bit more than 50,000 generalized United States tax returns. And it was over multi-year period of time. And we already knew these records included positive and negative audit results of people with different characteristics, and then with companies, mid-size and small business with different characteristics. And usually, if you're familiar with tax return forms, they have more than 300 attributes, and different combinations of these attributes can lead to some interesting violations of tax returns. And our objective was to discover business rules capable of identifying suspicious tax returns. So they call this red flag rules. But what was very important, nobody knew what actual rules were applied over this time period. And this is a huge secret, government secret. Of course, nobody could share. Actually, even people with whom we work, they did not know these rules. They have some guesses, but they did not know rules. And when we worked with them, they told us you cannot use this all 50,000 training instances at the same time. They affect differently different goals, different classification objectives. So we, as a result, they recommended us to split them, all these training instances based on different combinations of factors, and they suggested to remove some outliers. And basically we worked very closely with subject matter experts who were not programmers, but they were real experts in taxation policies, and it was mutual work over several months. And we, when we generate rules for them, it was a lot of surprises. They loved They understood this result, they loved results, and I have a lot of interesting stories about this. But basically, it was success because, and you can see some official report from them that they automatically discovered rules were meaningful for their business analysts, and they got exactly what they wanted. And was even results that if such rules were applied, it would save about 3% to IRS, and if you apply this to real world, we are talking about billions of dollars saving. So this was success, but unfortunately, it was that time it was only in Office of Research for IRS. But it was success story. If we apply advanced rule owner today, it would be much better. Not only results, but the process would be more simple, and people, the subject matter experts themselves, can improve these results. Okay, and this is basically, I described new functionality, and I just want to share, to stress not my optimistic view, but more pessimistic view. Machine learning in general has common limitations, and people know this for many years, right? Because machine learning is not something what was invented yesterday. It's more than 40 years. And one of the notorious examples at the beginning of machine learning was that the machine learning algorithm can find dependency between ability to read and shoe size. So this sounds funny, but it just stresses that machine learning algorithm, any statistical algorithm, does not truly comprehend the concept of what they're dealing with. Everything for them is a statistical by nature, so it's just numbers or strings without real understanding, and they find good patterns and dependencies. Of course, a human can transfer this to dependence ability to read to age, for example, and age certainly connected to shoe size, or in many cases. And so this is a good, so nobody pretends that we actually understand, machine learning understands anything. There are no understanding here. And contrary to what sometimes or frequently Gen AI pretends. And if you have garbage in, garbage out, there is no magic here. If we have poor data, we will get poor results, and we will probably get very low average accuracy. And rule owner, actually, we even specifically included notorious problem vacation days, and when we tried it, generated rules had no practical sense. It's not just errors, it's just very low accuracy, and because it could not extract the same concept what human extract from just from based only on samples. But if you provide additional natural language description and apply rule LLM, it would be much better results. Something what is intact with Greg representations. And I also want to stress that machine learning algorithms do not hallucinate. People hallucinate, that's true. For example, I remember when I was a young programmer and built regression analysis software for my research company, then we have a PhD level scientists, I call them pseudoscientists. They used my software to justify their results what they already expected. And so they actually removed not just even useful real data to make correlation coefficients that was initially 0.4, and they just tuned their data, applied the same software to justify these results, making correlation coefficients 0.9. And so this is certainly results were fake, and we should be very careful when we offer such tools to customers who are not really decent people. And so even results that could look good, they not always represent the reality. And also, just probably my last slide is about lesson learned. This is you saw that I applied to these examples to relatively simple examples, but it was much more. If you download Rule Owner, you will find many much more sophisticated examples. But anyway, usually you should not try to apply such tools to huge models right away. It's much better to split big monolithic decision models to much smaller sub-problems and use select, filter examples for these problems and solve this problem and present them as a separate business models. Then you will have loosely coupled decision models, and you will deploy them and loosely coupled decision services or agents, and then the most important part becomes what people talk about this, it's service orchestration. And service orchestration is also business logic that could be presented in business rules. And we can invoke different services based on the service orchestration, or we can apply MCP to do this work. And this is certainly a very practical approach where we combine different tools to build working decision models. So this is my conclusion, that advanced rule owner aims to help business users to create working decision models based on examples. It automatically builds all major business context for decision models and allows us to deploy these models, enhance these models. And what is important, it's not just words. Everybody can download this. It has free evaluation version. You go ruleowner.com and you can try it on your own problem. And we actually welcome you because we need more real world examples to do it. That's the end of my presentation, and I would be happy to take questions. Okay. Questions? Alan?
Hi, Jacob. Yeah, I'm interested in the point you made about this classic confusion about vocabulary being correlated with shoe size in children. And you characterize that in your slide by saying that machine learning algorithms don't understand what they deduce, and that's. But I don't think that's quite. I don't think that quite gets to the heart of the issue, which is really that it is not possible to deduce causation from correlation in general. Judea Pearl has expressed this beautifully in his book of Why. And so his conclusions are that all you can do is allow people to assert their understanding of causation and then use those models to understand correlations and to test your ideas. And I'm particularly interested with your use case there of the IRS, because the first rule-based system I ever built was for the UK Inland Revenue, and for detecting suspicious tax returns. So this use case is very close to my heart. And what we found there was that a simple set of rules, no matter how derived, were not really good enough. What we needed was a huge database of, for example, businesses across the UK and the typical sorts of profit they tend to make depending on what the business is and where they are situated. So you would have data on the average profit of a butcher in Halifax. So you can look at a particular tax return and decide whether the results that they're posting look reasonable. But of course, which parameters you use to decide whether the thing is reasonable or not varies from from job to job or from place to place, and we had to involve quite a lot of human effort in the data mining to provide the factors which are then acted on by the rules. So I was interested to know how you got on with that in your IRS use case, and how well your rule extraction methods worked in that area.
Yeah, I can talk about this for hours, and actually, you're right that it's not just does not work from first attempt, and the involvement of knowledge from subject matter experts was key, and that's why I'm talking about this filtering and splitting the entire model in multiple model, very specific model, and putting business knowledge. We call this training rules. And because training rules reflect the latest state of economy in this case, and there are involving them and letting business people express everything in business terms was a key here. And when we discovered rules, they always interpret them much better than us technical people. For example, it was one case when my product manager in IRS did presentation, and he demonstrated generated rules, and it was a steering committee, and in front of steering committee he shows rules, and suddenly this he saw that one of rules says if tax return number more than this threshold, then, and he thought, I have to apologize, I need to exclude tax return number, it makes no sense to have tax return number, it's not meaningful. And somebody told him, stop. It is meaningful, because if it's more than this number, it means it was filed later, and it has business sense. And we saw this every time. The more they analyze them, the more excited subject matter expert became, and they really were people who loved the results. And this is, and we had a lot of other rules. For example, we had rules, generated rules if a person older than certain age and spouse is younger than certain age, and donation were more than certain amount, then it was red flag. And everybody thought, oh, this is old guys with young wives don't really donate. So, and this was a trend there. But so it was some funny stories, was real stories, but ability for subject matter experts to add their real understanding of problem was the key for success, and it always will be. Actually, what I like in Gregor's presentation, that's what he described about this his approach when he added these prompts, and this is certainly LLM has something to add to this context. And Denis, please. Unmute yourself, Denis, unmute.
Thank you, Jacob. That was a great presentation, really appreciate. So a couple of things came up to mind, and I wanted to see where you're going with your thinking. So the idea of using filtering for doing some kind of chunking of samples so that you have chunking of your rules that will become separate decision that can be two things I'm wondering. One is, from what I understand, it requires the intuition of the subject matter expert to know how to craft those filters so that it will generate something of matter in the graph of multiple decisions. I was just wondering if you thought of a way of maybe exposing what those potential filters could be, at the higher level of abstraction, so that you could see by either doing some chunking of the data or because it seems like if you reduce your sample set like this, you have less data sample and thus more danger of drifting into your rule generation. And there's probably a balance of amount of data, number of filters you want to apply, and that seems to be some kind of an optimization problem itself.
Yeah, it's an interesting point. I didn't think about optimization, but what we did, what was important, that we gave all control to IRS subject matter experts. And because they could do this filtering, they decided what does it mean outlier in this particular situation. Then one of important thing was let's call them negative and positive results of audits, and how many negative and positive instances you have. And usually it's much better to have more negative instances than positive, because you can filter out bad situations. And they never got these rules from the first attempt. The project, it was 3 phases, and during the last phase they actually come up with rules what they felt the proper rules. It was not automatic, but listen, this already we went through many years. Nobody knew about LLMs that time, and probably what I would not say optimization in this case, but I would say filtering results of generated rules using LLM. And this would be very, very interesting. For example, when I told you about this, what you said balance between positive and negative results, it could be quite interesting. And so this is something what research, it's an area of research, especially in such situation as taxation, when saving a small percent can result in huge saving overall. And hopefully I'm answered. And Jan has question. Jan, do you want to ask, or you want me to read?
You probably won't have time to answer the question, but I was just an observation to this nice talk. But if you learn from cases, things that never happened, how can you learn from this?
You know, just I don't want to, I thought I was clear when I said it's not a universal tool. It's still you need to massage data, you need to use this remove outliers, what you just call, we call them outliers, and you have filtering rules. There are different types of rules. It's not like one simple table. You have outlier removing rules, then you have rules removing unnecessary positive results, and only humans, normal humans, writing normal training rules, they were not discovered, they were manually created, and that represents their understanding. So we gave them tools, traditional, let's call them DMN-like tools, that they can represent their understanding of problems, and this was a key for success.
Yeah,
right?
Fine. Okay,
okay.
Thanks.
Okay, thank you everybody, and this is the end of my presentation, and let me stop recording.